Welcome back. This is Saurabh Basu from ClassCastException. So we have already covered equals and hash code earlier, the contract that tells Java when two objects are the same. Okay. So we now cover comparable and comparator that define how custom objects, that is some class that you have written, those are ordered and sorted. Okay. So comparable will modify the actual class to give it a single sorting logic, but comparator is defined externally, external to the class, and it will provide multiple sorting. Okay. So if you think in real world analogy, what happens there, say, so you think of the string class or the integer class, right? So by default, string always sorts alphabetically, right? A to Z, and numbers always sort numerically, 1 to 10. So that is very natural and built-in behavior of the string and the integer class because they implement comparable. So when you need to sort a collection of your classes in Java, Java does not automatically know how to order them. Okay. So should say if you have written a class called employee, should a list of employee objects be sorted by their ID, their name, or their salary? That is the question, right? So to answer this, Java provides two distinct interfaces. Okay, we have to remember this. So what is the question here? So you have written a class called employee, and that employee class has ID, name, and salary. So if you make a list of such employee objects, so how it will be sorted, right? So Java will provide two distinct interfaces for this. One is comparable T. So it's for natural ordering. So that class, it defines how its own instances compare to each other. Okay. So one method and built into the class itself. That's how comparable works, right? So, but comparator T is an external ordering. A separate object defines how to compare instances of another class. Okay, it's a separate object. So one method defined outside the class. So you can have multiple comparators for the same class, sort by name, sort by salary, sort by hire date, all as separate comparator objects. Okay, so the OCP exam tests both the method signatures, return value contract, etc., etc. We are going to discuss all that in detail now. Okay, first we'll start with comparable. Before that, if you are liking this OCP series, I request you to please like and share and subscribe and comment here. Okay, so now we'll start with comparable, right? So comparable defines the default way that objects of this class should always be sorted. Okay, so we call this natural ordering. So if we think in the real world, so think of the string class or the integer class, right? So by default, strings always sort alphabetically, A to Z, and numbers always sort numerically, 1 to 10. So that is their natural and built-in behavior because they implement comparable. So we have given the code here. So we have given a class here called employee. It implements comparable employee, right? So what does it do? We have written this class that allows it to sort by salary. Okay, so objects can be sorted by their salary. So there are various kinds of employees, right? So they can be sorted by their salary. This is how this class has been defined. So we see that string name, double salary, those are instance variables. Then we have a constructor, employee string name, double salary, this dot name equal to name, and this dot salary equal to salary. Okay, and then we have at the rate override, right? So public int compare to employee other. Okay, and here we see return double.compare this dot salary comma other dot salary. This is where we are comparing, and to print out we are overriding to string here, at the rate override public string to string, return employee name salary salary. Okay, and in the class main we are just adding those things here. The employees here, employees dot add new employee Alice, Bob, and Charlie. And then we are printing out before sorting what was the details, and then what we are doing is that Collections.sort employees. Okay, and then we are printing out after sorting. So you'll see the result that before sorting Alice, Bob, and Charlie, but after sorting it's Bob, Alice, and Charlie. Okay, same thing if you wanted to do for ID, right? Sort via id, you could have done the same thing. In the compareTo method, you would have done that return integer.compare this.id comma other.id. okay, so this will compare this employee object's id to another employee's id. okay, and similarly we are doing a collections.sort list here, and you will get the result accordingly. okay, so what is this compareTo method, right, in comparable? So when you implement public int compareTo employee other, so you are writing a method that is sorting algorithm like Java's team sort will call millions of times to rearrange items in a list. okay, as you know, in compareTo we are sorting two objects, right? So the sorting algorithm here, it will ask one question only. So does the current object belong before or after the next object? okay, so in the method. So here is a breakdown of how it is how Java interprets your return value, right? So you are returning a value from this method, that is int, right? The method is public int compareTo employee other. So if you return a negative integer that is less than 0, it will mean this is smaller than the other. okay, this should come before the other in ascending order. And if you return 0, it will mean this is equal to other for sorting. okay, and then if you return a positive integer that is greater than 0, it will mean that this is larger than the other. It should come after the other object in ascending order. So one misconception that can be that you must return exactly -1, 0 or 1. okay, so that is not true. So whether you return -1 or -1000, the effect is the same. okay, so this will come before the other object. okay, your custom object. So say you have two persons, two employees, right? Bob's salary is say $50,000 and Alice's salary is $75,000. So if you do int result equal to Bob.compare to Alice, right? What will happen inside Bob.compare to Alice, right? So this is Bob, this is Bob, so that is so you are comparing Bob with Alice, right? So you are comparing Bob with Alice. So this is Bob is 50,000, other is Alice 75,000. Since 50,000 is less than 75,000, the code will return a negative number, that is -1. So what Java will do? So Java will see the negative sign, know that Bob is smaller, and keep Bob before Alice, because this is ascending order. okay, now we shall discuss double.compare and integer.compare and why they are correct solution for certain cases when subtraction fails. okay, and there will be some kind of traps there. okay, say you have public int compareTo employee other and return this.id minus other.id. So logic is sound, and if this.id is 10 and other.id is 5, then 10 minus 5 is 5, which is positive, meaning 10 is greater than 5. However, integers in Java have strict limits. okay, that is bounded by integer.minimum value, mean value, that is -2147483,648, and then we have integer.max value 2147483,647. okay, so when you perform arithmetic that goes outside these boundaries, right, the number will silently overflow and it will wrap around. Say like you have seen an older car. If you have seen an older car that has a mechanical odometer, right? So that mechanical odometer will track the total mileage, how far the car has traveled, right? So once it reaches say 999,999, it will flip back to 0. Similar thing also will happen here. okay, so say you are comparing two employees with extreme IDs, which is not practical, but that can happen, right? So say you have this.id, then equal to integer.max value 2147483,647, and the other ID is -10, right? So if you do a subtraction here, so result is 2147483,647 minus, then within bracket -10, so it becomes 2147483,657. But 657, this 2147483,657, it is larger than integer.max value. okay, so because it is larger than integer.max value, it will roll over into negative number and it will become what? -2147483,639. So because the result is suddenly a negative number, so Java's sorting algorithm will think what? That integer.max value is smaller than -10, which is totally wrong. So your list is now sorted totally incorrectly. It is a bug. Then another thing is there that for decimal numbers, double and float, so subtraction is broken for two entirely different reasons. Okay, so imprecise binary math and truncation during casting. So we have floating point numbers, right? So floating point numbers are represented using base 2 or binary fractions. Okay, so because of these, certain decimal numbers like 0.1 or 0.1 or 0.2, they cannot be represented with perfect precision. Okay, say you subtract 0.3 minus 0.1 plus 0.2 within bracket, right? It should be 0.0. However, the computer, it might calculate it as 0.000000000000, then 0004. Okay, so while these two values should be considered equal, right? That 0.3 minus 0.1, 0 plus 0.2 equal to 00, right? Returning 0, but subtraction approach will return a tiny positive number. Okay, understand that it will return a tiny positive number. So Java will think that they are unequal. Then there is another problem in the compareTo method, right? So compareTo method must return an int. So if you subtract two doubles, the result is a double. To return it, you have to cast it into an int. So if you have public int compareTo employee other and then return int, you are casting this dot salary minus other dot salary, right? What will happen? Say you are casting a double here, right? But casting a double will truncate the decimal part. So imagine, say this dot salary is 50,000.75 and the other dot salary is 50,000.25. So subtraction will be 0.5. So you have to cast it using int, so it will truncate it down to 0. So Java will read that 0 and confidently declare that both salaries are identical. Okay, so it will totally ignore the fact that there is a difference of 0.50. Okay, so how do you solve all these traps and all these problems, right? So to prevent both of these issues totally, so Java provides a built-in static helper method inside primitive wrapper classes. Okay, so primitive wrapper classes what? Say integer, then long, then double, all with caps starting, right? So we have integer.compare intx, inty, then long.compare long.x, long.y, and double.compare double.x, double.y. As you see, those intx, inty, long.x, long.y, etc., those are primitives. Okay, so these methods do not use subtraction. Okay, so they use relational operators less than and greater than to evaluate the numbers very safely. So we should use these only, that double.compare this dot salary comma other dot salary. So this way you bypass the risks that we discussed earlier, right? The floating point math and integer overflow. Now in comparable we have three rules. These are called comparable contract. Okay, so one is anti-symmetry. It means if x dot compared to y is greater than 0, then y dot compared to x must be less than 0. Okay, so if object x is greater than y, object y, then object y must be smaller than object x. Okay, then we have transitivity. So if x dot compared to y is positive and y dot compared to z is positive, then x dot compared to z must be positive. Okay, so that means in simple language, if Alice is taller than Bob and Bob is taller than Charlie, then Alice must be taller than Charlie. Okay, then the third point is consistency with equals. Okay, so this is recommended, not that required, but let's understand this. If x dot compared to y returns 0, then x dot equals y should return true. Okay, so this consistency with equals, this is strongly recommended, okay, rather than strictly required. So it is strongly recommended by the Java, because if you violate it, it may introduce a massive trap here using shorted collections like tree set or tree map. Okay, so let's understand this more. So there's a conflict of hash set versus tree set here that's introduced here. So in standard collections like hash set or hash map, they use hash code and equals to find duplicates. Okay, shorted collections like tree set or tree map, they totally completely ignore equals. Okay, they rely entirely on compareTo to find duplicates. Okay, but standard collections like hash set or hash map, they use hash code and equals to find duplicates. Okay, this is the fundamental difference. Now what is the problem that happens here is that imagine you have an employee class where equals compares ID, right, but compareTo compares salary. So what happens here, if you have employee then emp1 equal to new employee Alice, and then emp2 new employee Bob, and Alice's salary is 50,000 and Bob's salary is also 50,000. So they both have same salary and but different ID. Okay, so emp.equals emp2, right? So it will return false because their IDs are different, so they are unique persons. Okay, but if you do emp1.compareTo emp2, so it will return 0 because their salaries are exactly the same. Okay, so if you add both of them to a hash set, the hash set will check equals, it will see two different IDs and store both employees. Okay, which is correct. But if you add both to a tree set, right, the tree set will check compareTo, it will add Alice first, and when you try to add Bob, so compareTo will return 0. The tree set will reject Bob totally and throw his data away. Okay, so if there's a question that asks you about a class where compareTo equals 0 but equals is false, so you have to look closely at the collection that is being used. So if it is tree set or tree map, then data loss or missing entry will be the result. Okay, now we are getting into comparator. So we have an employee class here with instance variable name and salary and constructor, then getters, get name, and then we have a toString here to print the object, and in the public static void main we have an array list, and in the array list we are adding various employees here, Charlie with 90,000 then Alice with 75,000 salary, and then Bob with 50,000 salary, right? Then we have comparator employee, then the variable name equal to Comparator.comparing employee get name. Okay, and then what we do is that variable that we are getting by name method ref, then we are doing employees.sort by name method ref. Okay, what is employees here? Employees is the array list, and what is by name method ref here is the comparator reference. Okay, so once the program is run, we see that we have a sorted list and they are sorted by name here. Why? Because we had Comparator.comparing employee get name. Okay, so initially if you see, the original array list is printed, but after that we sorted by name, so we see that they are sorted by seller name, and it's Alice, Bob and Charlie. Okay, now comparator is in java.util and is classified as a functional interface. Okay, so a functional interface is any interface that defines exactly one abstract method. That particular interface just has one abstract method only. Okay, and for comparator, the method is, so comparator is what? Comparator is a functional interface, and what kind of only one abstract method it should be having? It has int compare t01 t02. Okay, so even though the method takes two arguments instead of one, unlike comparables this.compare to other, the integer output remains completely identical. Okay, so here also if you have negative int that is less than 0, then first object A belongs before second object B, and if the return is 0, then both objects are considered equal for sorting, and if it is positive, that is int greater than 0, then first object A belongs after second object. Okay, so let us now discuss how to chain comparators. In real enterprise applications, sorting is rarely based on just one field, right? So you have seen that in Amazon or any other website, that sorting is rarely based on just one field. So there will be primary short key, say salary, then there will be a secondary short key when the primary values are equal. For example, say name, say two persons' salary is same, so you want to sort via name after that. Then sometimes even a tertiary short key is there, which is a tiebreaker. Okay, so say name, salary is same, name also becomes same, then what will be a third tertiary short key, so that will work as a tiebreaker. And then there will be a mix of ascending and descending ordering depending on business requirements. Okay, so for example, if you have an employee report, it probably will be sorted by department, ascending, then by salary, descending, then by employee name, descending. Okay, so this kind of multi-level sorting is extremely common, okay, in enterprise software, because in the database always there will be many records that with the same value for a particular field. So this kind of sorting is required. Okay, so this is called multi-level sorting. So if you see the code here, we have a class employee with two instance fields, private final string name, private final double salary. Then we have a constructor, and then we have getters, get name and get salary, and then we have overridden string to string to print the object, and then we have a class name. In the class name we have a new array list, employees.add, with that we have added Charlie 75,000, Alice 90,000, then employee David 50,000, and then Bob 75,000, and Edward 50,000. Okay, so here we see that Alice with 90,000 is a unique high salary, but then David 50,000 and Edward 50,000, they are tied for salary. Okay, then Bob we have 75,000, that's again tied with Charlie. Okay, 75,000. Now that sorting should happen, and Bob should beat Charlie alphabetically, right? B comes before C. So here we print it before. So here we have comparator employee by salary descending then name. Okay, so that reference name we have kept it like that by salary first descending salary, then by name sorting. Okay, so we have equal to Comparator.comparing double employee : get salary, then dot reversed dot then comparing employee : get name. Okay, so this is the comparator reference. Then you just have to say employees.sort by salary descending by name. Okay, by salary descending then name is the comparator reference. Okay, and employees is the array list. Okay, then you have to print it out, and it will print out. So initially, if you see, before sorting, first comes Charlie, then Alice, then David, then Bob, then Edward. But after printing out, what we'll see, first will come Alice with salary 90,000, then Bob with salary 75,000, then employee Charlie with salary 75,000, David salary 50,000, and Edward salary 50,000. Okay, so like we discussed that there are two ties here, right? 75,000 tie. So both Bob and Charlie have the same salary, but because Bob starts with B and Charlie starts with C, so Bob shifts ahead of Charlie alphabetically. Okay, because we have dot then comparing employee : get name. Okay, so how it was done? Okay, so let us go through it step by step. So when employees.sort by salary descending then name was called, Java started comparing pairs of employees. Okay, so first is Comparator.comparing double. Okay, and employee : get salary. Okay, so in scenario A, say we are comparing Alice, which is $90,000 versus Bob, who has $75,000 salary. Okay, so we are saying dot comparing double, Comparator.comparing double, then employee : get salary, right? So what Java will do is that Java will compare their primitive values. Since 90,000 is greater than 75,000, it will return what? It will return a positive integer. Okay, and then what we'll do, next line is dot reversed. So this will intercept that one that it was returned from the first line, and then it will multiply it by -1. So it will be converted into a negative integer. that is -1. So outcome will be, because the result is negative, so Java will place Alice before Bob. Okay, the chain will stop here because there's no tie here, right? Salary is not tied, so then comparing will not come at all. Then let us say it is comparing Charlie 75,000 versus Bob 75,000 salary. Okay, so now what will happen is that the first line is what? Comparing double, right? Employee gets salary. So since 75,000 equals 75,000, it will return 0. Okay, and if you do reversing also will make it 0 only. Then that it will go to the third line. Okay, dot then comparing employee get name. Okay, because salary result was exactly 0, so Java knows that there is a tie here. Okay, so it will then compare the strings Charlie and Bob. Then Charlie.compareTo Bob, it will return a positive integer, because since the result is positive, Java will know that Charlie must be placed after Bob. Okay, we also have then comparing double. Okay, so then comparing double is also powerful. It's a built-in method in Java comparator used for chaining comparisons. Okay, now we shall discuss then comparing double. So the then comparing double is a powerful, very built-in method in Java comparator. Okay, it's used for chaining of comparisons. Okay, so say your primary sorting rule, it determines that two objects are equal, right? Then this then comparing double, it allows you to set up a tiebreaker rule, okay, based on a primitive double value. Say you are sorting a list of employees, right, and your primary goal is to sort them alphabetically by their name. However, you have two employees named Alice, so who should come first, right? So instead of writing if-else block inside your comparator, you can use then comparing double. So then comparing double will do what? So it will say that sort by name first. If names are identical, then break the tie by sorting by salary. Okay, so we have a class employee and we have three instance variables: department, salary, and name. Then we have a constructor, we have getters, then we have a toString method, and then we have the main. Okay, within main we add two employees of HR department, 60,000 Charlie and then 85,000 Alice salary. Okay, and then we add three employees in the IT department, 95,000 Edward, 75,000 David, and 75,000 Bob. Now if we do before sorting, if we print them out, they will print accordingly like we added, right? 60,000 Charlie, 85,000 Alice from HR, and then IT 95,000 Edward, 75,000 David, and 75,000 Bob, right, in the IT department, like we have added here in the code. Now we are going to sort them, right? So for the sorting logic is that we do dot comparing employee get department, then comparing double employee get salary, then reversed. So reverse function will reverse both these two, right? So here IT will come before HR, right? Because normally if we do A to Z, that is ascending, so it will become HR will come before IT. But here we are reversing it, so it will become descending, Z to A, right? Z to A. So IT will come before HR because of the reverse thing. Reverse will reverse both these functions. Like then we'll come to salary sort, that is also reversed. So within the IT group, what will happen that Edward is positioned first because it is 95,000, because the reverse will flip the salary sorting to descending order, the high to low. Okay, it is high to low. So what will happen is that first we'll get employee IT, then salary 95,000. Okay, so name sort, it is untouched. Okay, so in IT department we have two persons, Bob and David, whose salary are same, right? So how to proceed with that? So Bob and David here are logged in a very dead tie here, okay, within the IT department with 75,000. So because then comparing employee get name was added after the reversed call, okay, what will happen is that it will remain strictly ascending, A to Z. Okay, so ascending means A will come before Z, right? So Bob will jump ahead of David. Okay, so that is why once we print them out, so what we see is that we see employee in the IT department, then Edward comes first, then Bob, and then David. Okay, so first sort is this, in this chain sort is that department, right? So IT is coming before HR because it was reversed. Okay, then salary was sorted. Okay, it became descending 95,000. Then within salary also, salary group also, we have two persons, right? There's a conflict. So how to sort them? It is not reversed, right? So that's why it's ascending. So name Bob will come before David. That's how all this code, this one works, okay? So if we come to comparable versus comparator, right? In the exam, when to use comparable, right? So when there is one obvious natural ordering for the class, like string has natural alphabetical ordering, right? And integer also has natural numeric ordering. So local date has natural chronological ordering. So if someone asks what is the default sort order for this class, it will be comparable, okay? And when you will use comparator, so when you need multiple different orderings for the same class, when you do not own the class and cannot add comparable to it, when the ordering is done sometimes by name, sometimes by salary, sometimes by department, all that stuff are concerned. So at that time you use comparator, okay? So that's all for this video. Thanks for your time. Hope you understood it. So you have, if you have liked this video, please kindly share, like, comment and subscribe. So apart from our OCA series of questions, we have already come out with our OCP series of questions. So you can check them out in the following videos. The links are given there. Thanks again.